Okay, hi everybody. That's loud. There are so many of you. This is really great. I'm really happy to be here. So I work for this company called SoundCloud. Show of hands, has anybody heard of it? Yes, good. So we're this website. We put your sounds in the cloud, I guess. No, we're more than that, actually. We're actually an API, and we have many clients. So our website is a client, our iOS app is a client, and so on. Behind the API, we're actually a universe of services. So we're like a service-oriented architecture. And at SoundCloud, we are polyglot, which means we used a lot of languages in the back end. So one of those languages, for quite a long time now, for over 2 years, has been Go. And we've been really happy with it. We've been kind of an early adopter, and Go use in the company has expanded quite a bit. So I want to talk quickly about a few of the projects that we have in Go, just to give you guys some context. Starting off, we have a project called Bazooka, which is like our platform as a service. Spiritually, it's very similar to Heroku, or Flynn, I guess, is a new one that's just kind of been released based on Docker. Our entire traffic tier is largely like Nginx and HA proxy, kind of what you'd expect from any big website. But all of that is orchestrated by Go services. There's Go services that are acting as the glue. Media streaming, again, similarly, all of our content ends up on S3 at the end of the day. But the upload process, the transcoding, the thing that builds the URLs to get you from your browser to the content, that's all managed by Go services as well. Search and Explore are powered by Elasticsearch and machine learning models, respectively. But the thing that interfaces those things with the rest of our infrastructure is all Go. So whenever you do a search or you click on any of the Explore links on the main web page, you're going through a couple of Go services. We have a telemetry and metrics service called Prometheus that we're working on. It's pure open source if you're interested in this sort of thing, github.com/Prometheus. That's pure Go, and we're transitioning most of the infrastructure over to be using that. A project I'm working on, which I'm really excited about, is our new stream backend. So currently, if you have an account and you go to the web page, you see a stream of all of your latest tracks of people you follow. That's currently powered by Cassandra, but we're ripping that out and replacing it with a mostly pure Go backend. Very exciting. Similarly, HTTP live stream, we have a prototype implementation that we're working on in pure Go. It's still a prototype, but we hope at some point to transition most, if not all, of our web streaming over to that. And many other small product features. So all of these projects are driven by probably about a half dozen teams using Go. In those teams, they're comprised of maybe a dozen or more Gophers, most of which who are working full-time in Go or close to it. So after, 2.5 years, a dozen teams, half a dozen teams, a dozen developers, quite a few projects, we've developed or evolved kind of a set of best practices, which I thought might be interesting to share with everyone. I think we're maybe unique in that we've been doing this for maybe longer than a lot of people. We're at a large scale, and we have quite a lot of heterogeneous experience. So maybe this is going to be an interesting talk, especially to those of you who are just getting started in the Go ecosystem and want to maybe learn some things from someone who's been doing it for a while. So here are the main topics that I want to run through. Things like how we set up our dev environments, how we set up our repos, basic formatting and style ideas, how we do configuration of processes, how we do logging and telemetry, validation and testing, dependency management, and building and deploying services. So let's get started with dev environment. One thing we settled on is basically a single Go path. For a long time, people experimented with having multiple Go paths, one Go path per project. But in the end, that proved to be kind of more hassle than it was worth, and we're all pretty happy with this. So best practice, perhaps. We clone our repos into their canonical path as expected by the Go tool. So if you're working on a project called foo, you would clone it to this directory on your file system and work there directly. We tried a bunch of hacks. A lot of us want to maintain our old repo structure, code layout idioms and conventions, but it proved to be more hassle than it was worth. In terms of IDEs, a lot of us use Vim, with some of which use the various plugins. Like I think Go Vim is a brand new one. It's pretty good. Many of us use Sublime Text with Go Sublime, myself included. Quite nice, recommended. A couple of people use Emacs, and nobody really uses any IDEs. I don't know if that's a best practice. It's just kind of an interesting note. OK, that's our dev environment. Let's talk a bit about repo structure. And here, the secret is to keep it simple. Many of our services are just like a half dozen files that are all in package main. And if you can keep it to that, then you should. And so quite a lot of things look like this, maybe with some extra Go files and test files, of course. But if you can do it this way, just do it, right? There's no point to adding structure that you don't necessarily need. But maybe you do eventually necessarily need some structure. So when it comes time to break out a subpackage, we find the best way to do it is like this. Just a note, if your subpackage contains only one file or one structure, you don't need to break it out. Just keep it in package main. And another note, when you import this, you use the fully qualified name. So import GitHub.com, SoundCloud, whatever, foo in your package main. This takes you quite a ways, especially with like maybe one or two packages, sub-packages. Sometimes you even more need to have multiple binaries. So for example, a project might have a worker process, a janitor process, a server process, something like that. So if you need to do that, then we find this works pretty well. You have separate package mains in subdirectories, and then all the support code from there. Notably, there's no SRC directory in any of these repos. Unless you're doing something with vendoring, that's kind of a bad smell, we find. OK, let's talk about formatting and style. Here, we've had it easy for a couple months. Mr. Brad released this code review guidelines from Google internal. And while we had a style guide before that, it was almost identical. So we just use that. We have also this lovely tool called GoFormat, which we always run with the defaults. Don't mess with the defaults. In fact, I think even some of the defaults are going away in the next release of the GoFormat, or some of the non-defaults. Like you'll only be able to indent with tabs. Great. Code review guidelines. We have a couple other things that are maybe a bit idiosyncratic. We prefer to avoid named return parameters unless they're really like the right tool for the job. I'm not sure exactly why. I guess it's just like historical convention. Similarly, we avoid make and new unless you need it, like for chans, or you already know the size of the thing you're allocating. We prefer the struct literal syntax, especially for just pure blank stuff. And we like to use empty structs to convey sentinel value stuff. So if you have sets or channels that you want to use as signals, use empty struct instead of bool or whatever else, empty interface or something. It really clearly conveys the meaning that there's no information in this part. So yeah, do that, best practice. Another fun thing in terms of code formatting is we've learned to break long lines on parameters. So if you come from like a Java background, you probably do stuff like this. Don't do this. There's no reason to. Much nicer if you have it look like this. Go lets you keep these like trailing commas on the last line of the last thing. Really nice. Take advantage of it. It's Go format like valid, so to speak. Similarly, when you're constructing things or calling constructors, use this style rather than compressing it all onto one line or breaking on 80 characters or whatever. Cool stuff. OK, let's talk about configuration. We're mostly 12-factor apps. And that means that we're intended to extract our configuration from the environment. That's cool. For a while, we tried config files. For a while, we tried more complex flag packages. But in the end, we just stick with package flag. We think that it provides kind of the best value for money. We didn't really need any of we tried the other things, but we didn't really extract much value from it, especially now that the flag package has all the nice primitives that we want, like flag duration. Thank you very much, David. I don't know where David is. Much appreciated. So even though we're 12-factor and all of our configuration canonically comes in the environment, we still use package flag to pass it into our program. That means we have a start script, which converts environment variables into flag parameters. And we do that because flags are great. They're explicit documentation of your program. They define this like boundary between the environment that something runs in and the program itself. So highly recommended. There's a nice idiom we like to use, and that is to define your flags in your func main. It might feel a little awkward, but it has a couple of advantages. It forces you to scope your flags only to your main function, which means they're not in the global scope, which means you're never tempted in another module to reference one of them and thereby bypass like dependency injection, which is what you want to do. If you structure your modules in a way that you always accept the things that they operate on and accept the parameters that might be variable between different environments, then it makes your overall program much easier to test. So do this. Good. Okay, let's talk logging and telemetry. We played a long time with different log frameworks like log4j equivalents, things that provided different log levels. And in the end, again, best value for money is package log. We just log printf everything. And the reason we can do that is because our logs contain only actionable information. And that can mean two things. That can mean like errors that you definitely need to do something about, like critical stuff, like panic level stuff almost. Or it means it's structured data that's going to be consumed by another system. So for example, our search request router is going to print every request that it receives and all the context surrounding that request, like the client that it came from, how long it took, this sort of thing. And all that stuff is then consumed by our analytics pipeline to figure out how many listens we got in Angola that day or something like that. So that's the reason we can do that, recommended. But you're probably asking, what about all the other stuff that I care about that my program generates, like telemetry data? Well, we consider that telemetry data. And in the world of telemetry, there's kind of two ways of doing it. And I'd like to draw the line between a push model and a pull model. So push, you're probably familiar with. It's things like Graphite or StatsD or AirBrake. I guess there's a lot of products that work this way. It means you have your instance, and it's kind of emitting all of this telemetry information, all these metrics, to a known third party, which is then responsible for collecting, aggregating, doing analysis on it, that sort of thing. The alternative is a pull model, which is represented by the xvar package. It's how Prometheus works. And maybe there are others. Actually, I'm not aware of any, but maybe there are. And the way this works is you have your instance, and it's making the metric and telemetry data available. It's mounting it on an endpoint or whatever. And then the package, the third-party tool that's responsible for doing your telemetry, is scraping on some regular interval. So the push model is great. It's intuitive. It makes a lot of sense, and we do use it. But it has some costs, especially as your infrastructure grows. You actually end up like, at some point, your telemetry data starts overwhelming your actual like communication. And so then you have to start playing games with sampling, and then that's not great, and then blah, 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 a long time goes by, and it turns out that the costs of this push model are actually perversely incentivized. Like, the bigger you get, the more expensive it is. So it's been our experience that like best practice, you want to do the pull model at a certain point. And you want to use xvar style metrics, semantics. Another great benefit of the pull model is it allows you to introspect a running system, which is like super valuable when you're debugging or profiling or that sort of thing. Okay, let's talk about testing and validation. First, testing. We tried quite a few testing packages over the course of about a year in like a bunch of different situations. In the end, again, sounding like a broken record, the best value for money, package testing. We use data-driven, table-based tests. It's not that we have any specific complaints about the other packages. It's just they were to us a lot of ceremony and often like a mental shift in how we think about code with relatively little like value add on top of it. One thing that helps a lot if you're doing package testing is reflect deep equal. I don't know if you've seen this function, but it just takes two arbitrary structures and compares them like sort of byte by byte. That saves you a lot of boilerplate. So package testing is great for things like unit tests, unit-style tests. But there's this whole other class of test, integration tests or smoke tests or something like this. And that's a little trickier. It means typically that you spin up external services like a database or something full of fixtures, and then you integrate against that in your test framework somehow. There's not really a clear answer for this, but we did stumble on a really nice idiom that seems to work well. So if you have like an integration test.go, you can stick a build flag on it, just like a build flag for a different architecture or something. And go test takes a build tags argument just like go build does. In addition, you can define flags in the global space, unfortunately. What's interesting is that go test also synthesizes a package main, which I believe calls flag.parse. So if these flags are available to that flag.parse, then they'll be pulled in. And it means that go test -tag integration -h will have this set of flags, and only in that context will it have that set of flags. So you can use those flags to pass in things like the address of your database instance that you've just spun up, or anything you can imagine. And then in the tests, in that integration test.go, you can use those flags like this. So it's not great. You still need another thing to wrap it to spin up this services and then call go test, but it's okay. Works okay. Okay, let's talk validation. And by this I mean like automatic validation of your code. And for this we're really lucky. We have all of these great tools built into the Go tool, or alongside the Go tool. And I want to think about this in like the different stages of developing, right? So when you're typing your code, there are roughly like, well, I'll cut it into 3 stages. You're saving the file, you're running a build locally, and then you're committing and deploying, not necessarily scaling up in production, but you're pushing to your continuous build system or your continuous integration system. So for us, best practice on save, Go format, or Go imports, which is Go format ++ kind of. On build, it's not just Go build. We typically prefix it with a Go vet and a Go lint, and then throw a Go test actually at the end, because your unit test should be fast. Go vet and Go lint aren't meant to be taken as like gospel, but I haven't run into a situation so far where they couldn't be. You do have to like comment all of your exported functions, which is a good thing, but yeah, best practice perhaps. And then on deploy is typically when we'll run our integration tests. And the details of that depend a lot on your deployment system. If you use Travis, for example, you can do a pre-script and a post-script and all this fun stuff. So testing and validation. So far, there's really been nothing too crazy. And as I was doing the research for all this stuff, I realized like this is actually pretty boring, which in retrospect, actually, I think is a good thing, right? Like, it's our experience that these lightweight, pure standard lib conventions and idioms actually do scale, right? Like, we're a pretty big website. We have a lot of developers. We've been doing this a long time. And like after so many iterations, this is what we landed on. Maybe it's okay for you guys too. That's maybe the lesson of this talk. Oh, I forgot to mention, yeah, GoCov. I wish we used this more, but we don't. Maybe if we had a better continuous build system between building locally and deploying, that's where it would go. Yeah, we'll work on that. So, like, it's very tempting, I think, when you're coming into Go from a different background to want to carry over all of these conventions that you're used to, TDD, BDD. How am I going to pass configuration to my program without extensive, hugely documented command line flag options and regex parsers or whatever? And like, just maybe take a pause and think, do I really need all this stuff? And I think in a lot of cases, you ain't going to need it, right? You absolutely don't need like an error checking framework or Cucumber-style testing library just because your code base has grown beyond a certain size, right? Or Even worse, just because you expect it to grow beyond a certain size. Pull these things in when you need them, but ask yourself, do you really need them? Maybe not. Okay, let's talk about the gorilla in the room, dependency management. Whee! And we figured this out for us. Maybe it works for you. We'll see. This is a very simple flowchart. How important is your project? Question number 1. If it's maybe, yeah, it's important, but who knows? Then just do this. What's nice about this is that if there are problems, you're probably going to detect them at build time, right? And since build is, I hope, decoupled from deploy and run, then you have an opportunity to fix it. Sometimes that's not true. Sometimes you pull in dependencies and they break things in subtle ways. Ask me after the talk how I know about that. And those lessons maybe push the importance of your project up a bit more. So if your project is very important, then the answer is to vendor. And let me tell you a bit about vendoring. Maybe there's a space in the middle for import proxy, like gopackage.in. I think there's a couple other ones, maybe. We haven't found a need for them yet. Maybe there's a space for it. OK, so vendoring means copying your dependencies into your repo. And there's a few ways to do that. I guess there's purely manually, which is always an option. If you're using Git, there's like submodules and subtrees. And now there's like a whole suite of tools. I think the most popular one is GoDep. So copy your dependencies with submodules? No, don't. No. Submodules, in our experience, are broken by design. They're a pain in the butt to use. They don't behave like you expect they will. Don't do it. Subtrees are submodules like they're supposed to work. So we have a few projects that use subtrees that vendor with subtrees. It seems to work OK. We are aware of like GoDep. Haven't tried it yet. Maybe in the next like big push, the iteration, we'll give it a shot. High hopes. And it seems like that's kind of where everything is going. We'll see. So now we've copied the dependencies into the project. How do you use them? So it depends, I believe, on what you're building. If what you're building is a binary, which for us is 100% of the time, actually, then what you do is you have an underbar vendor subdirectory in your repo, underbar so that the Go tool doesn't process it as part of the normal go build .. or go test .. I believe it ignores it if it's prefixed like that. And then that subdirectory is going to act as the root of another Go path, which you're going to use. You're going to prefix that Go path in a sort of blessed build process that you're probably going to trigger from a makefile or something else. So if you're building a binary, that's how you do it. If you're building a library, I know what I would do, but I'm not currently doing this. So maybe it's like too much hassle to be worth it. I don't know. But it seems like the logical thing is to have a vendor subdirectory without the underbar. It's not going to act as a root of another Go path. It's going to act as like a subdirectory in your actual repo. And then you're going to probably use a tool to rewrite your imports. It's kind of annoying, but if you think of your library as like the unit, the thing that you're delivering to your users, your clients, that accomplishes some like piece of functionality, this is really, I think, conceptually the only way to do that coherently and have reproducible builds and have reliable tests and this sort of thing. So jury's out, but this is what makes sense to me. All right, last bits. Let's talk about building and deploying. And this is tricky because it's, I think, tightly coupled to your operational environment. I'll describe how we do it because I think it's good. Maybe it'll be different from your. I'm positive it'll be different from yours, actually. So building, there's like 2 stages. In the development build, on your machine, on your laptop, we just use Go build and whatever happens to be in your single global Go path. This is OK. It makes it easy to swap things out if you're testing things. But for official builds, we use Makefile. That's primarily because we're a polyglot company and we need like a lowest common denominator thing in our build toolchain, and Makefiles are it. Unfortunately, our build toolchain, like the environment is very bare, We have to bring our own compilers and environments and all of our dependencies for basically any definition of dependency. So our make files are like huge and terrible, and this is like a year of, after a year of experimentation and iteration, it's not good. We got to work on that. We'll probably fix the build environment before we figure this out, actually. Let's talk about deployment. And for us, the key abstraction in the runtime environment, in our production environment, is this concept of stateful services and stateless services. So what do I mean by that? So an example of a stateless service might be a request router, whereas an example of a stateful service might be MySQL, Redis, MongoDB, something which has persistence, something which mutates over time. Stateless systems, for us, abide a 12-factor-ish model, which is something I think it's been mentioned a couple times now. If you don't know about it, you should check it out, 12factor.net. Whereas stateful services don't really abide any particular model, kind of legacy of old times. When you deploy stateless services, the verb you use is to scale. So you scale up a stateless service or a particular revision of a stateless service with a particular configuration. Whereas stateful services are provisioned. They're typically tightly coupled to a resource or a particular machine or something like this. And for stateless services, the unit that you use is like a container. It could be Docker, it could be something else. Stateful services could be as well. We're not there yet. We hope to be soon. So for us, deploying services is mostly about deploying stateless services. And if you remember, our platform is like Heroku-like, so it works kind of like this. You take your repo, you push it to a special master. That triggers a build. If the build is successful, the container is available for scale up. So then you scale up your new revision, and here it can be as complicated as you want. You can scale up a canary, make sure it's not crashing, scale up a bit more, make sure you don't have too many errors, scale it up all the way, validate, and then scale down the old revision. So that's kind of all I've got. I hope this is like kind of an experience report from a company that's been doing this for a while, maybe longer than most. We're a large org. We've been running Go in production for a long time. And while these are like definitely informed opinions, they are just opinions, so take them with a grain of salt. But what I want to leave you with is that I think Go's greatest advantage is its structural simplicity. Simplicity at every like axis, right? And I think it's best if we all kind of learn to embrace that rather than attempt to circumvent it. And ultimately, this is, I think, the #1 best practice. So take it to heart. Thanks very much.